So let's take a look at the shell method to calculate volume. So the formula for shell method is the volume equals 2 pi times the integral from a to b of r of x, which is your radius function, times h of x, or your height function, dx. And I'll explain a little bit more of those functions in a bit. So let's say we have to find the volume of the region bounded by y equals sine of x and the x-axis from the x bounds of 0 to pi, and that region is being rotated around the y-axis. So if I were to draw a graph of this, we have the x-axis and the y-axis. The graph of sine of x from 0 to pi will look something like this, and we're going to rotate this region around the y-axis. Now, since there's a little bit of space between the region and the axis of rotation, and this will create a hole when the region is rotated, you might think that we have to use the washer method. And while it is true you can use the washer method, it's actually much more complicated. Since this is the graph of sine of x, and we're rotating around a vertical axis, such as the y-axis, we have to put everything in terms of y. And so we have to change y equals sine of x to be in terms of y. So then we have to isolate x. So then x would equal, when we inverse sine both sides, we can get rid of the sine of x, and we'll get x is equal to arcsine, or the inverse sine of y. But the problem with that is arcsine of y doesn't represent this entire graph. Only the left half of the graph is arcsine of y. The right half of the graph is going to end up being a different function. Although very similar, it's going to be negative arcsine of y plus pi, or pi minus arcsine of y. So there are two different functions. So then you have to plug in both of these into the integral, and it's going to end up taking a long time to actually solve this integral. And this is definitely not the easiest way to do it. And so the easiest way to do it is by using the shell method. So if I were to draw the graph again, we have sine of x from 0 to pi, the x-axis, the y-axis, and we're going to rotate that region once again around the y-axis. If I rotate this region, so I'm just going to duplicate sine of x just to show that it's rotated, in the center where the hole is, we're sort of going to create a shell-like shape. And what the shell method does is it's going to calculate the volume of this shell area so that we can actually find the volume of that region being rotated. So if I were to draw that shell, from the center of the shell to the outside, that is going to be the radius, or the r of x function. And the height function is just going to be the graph, or the graph of the function, sine of x. So this is y equals sine of x. This part is going to be the h of x, or the height function. So if I were to write the formula of the shell method once again, we get volume equals 2 pi times the integral from a to b. And notice how when you use shell method, if you're rotating around a vertical axis, you're going to use x bounds and put everything in terms of x. While in washer method, if you're rotating around the y-axis, you'll have to put everything in terms of y. So shell and washer are basic opposites when it comes to using x and y variables. So we go from a to b, or the x bounds, of r of x times h of x dx. And notice how we've already identified r of x, and we've already identified h of x. So if I plug in the numbers here, volume is 2 pi times the integral from a to b, and we're going from 0 to pi, those are our x bounds, of r of x. So r of x, this is basically the radius, and it's normally just going to be equal to x, just the x value, since the radius is the x value. Sometimes if you're rotating around something other than the y-axis, so let's say we were going to rotate, instead of the y-axis, around the line x equals -2. In that case, you would put -2, or the axis of rotation, minus x. If you're rotating around x equals 3, the line, vertical line x equals 3, you would put 3 minus x, and so forth. And you'd only have to do it for the radius function. You don't need to mess around with the h of x at all. You just need to put that number in for the radius, or for r of x. So once again, my r of x is going to be x times the h of x, and we identified h of x to be the function's height, which is the sine of x. So we have x times sine of x, which is h of x, dx. If I were to simplify this just a little bit, we get 2 pi times the integral from 0 to pi of x sine of x dx. Now I won't be integrating this by hand, but you will have to use integration by parts. But this will be, you could plug in this to your calculator to get to the final answer and find the volume. Now keep in mind that sometimes when you're asked to rotate around the axis other than the y-axis, typically a negative axis like x equals -1 as shown here, and you write for the formula 2 pi times the integral from 0 to pi, you would have to change the r of x, like I mentioned before, to -1, the axis of rotation, minus r of x, which is x, times h of x, which is sine of x. Sometimes when you have the negative number and you subtract the radius, or x, you'll sometimes get a negative answer. So when I plug this into my calculator, I get an answer of around -32.03. And this is just a small mistake. It's just because you put the line of rotation first before the function. And it doesn't matter because the answer, you can just make it positive, since volume is always positive, and this will still be the correct answer. So keep in mind that if you get a negative answer and you're correct, just change it to positive and you'll be fine.